Okay, so today we're going over scripting in Linux, specifically with um, the scripting language Bash. So I sent the link to the presentation in case you want to follow along in the chat. So what is scripting? Scripting is a tool that you can use similar to coding or programming. Scripting allows you to automate processes. You've probably scripted. I mean, you have scripted before if you've used Python, because Python also serves as a scripting language, um, as well as Perl and Bash. And today we're going to be going over Bash because Bash is also the Unix shell or the default Unix shell on most Linux operating systems. So what that means is when you type a command into when you type a command into a terminal, you're running a Bash command. So since Bash also serves as a scripting language, you can use it to automate Linux commands. And you'll soon see how that dynamic works. So when you're making your first script, there are a couple of necessary things that you'll need to do. So first of all, you'll need to have this line in the very first line of the file called a shebang line. And what a shebang line does is it points to the absolute binary path for whatever interpreter you want to use. So for example, since we're going over bash, then your shebang line would have this /bin/bash because that's the absolute path of the bash binary. And it essentially tells your operating system what interpreter you want to use. So for example, if I wanted to use something like Python instead, you might have user /bin/python, or depending on where your Python binary is. And as I said, this tells your operating system which interpreter you want to use so that when you run the file as a script, it has a default language that it's interpreting all of the lines as. Um, so the shebang line isn't exactly as necessary as it used to be, maybe. And what I mean by that is Linux by default executes scripts in the bash scripting language. So if you just run a file, then if you run a file and it has no shebang line, then it will just run it like it's a bash file. But adding this line allows you to run scripts in a different notation um, using this notation, and that also gives you syntax highlighting in case you are editing the script on the system, then you can get syntax highlighting from adding this shebang line. And it's also just generally good practice to have your code documented and have a shebang line in the file. And the second thing you're going to need to do to run a script is give it executable permissions. So by default, when you create a file on the operating system, then it won't have executable permissions, meaning you won't be able to run it as a script or a binary or an executable. And the way you change that is by using the chmod command. So chmod plus x will add the executable permission, and then the file name is the last argument. And after you've made it executable, then you can run the script using two different notations. Um, if you're inside the same directory as the script, then you can write a period followed by / and then the name of the script. Otherwise you can specify the absolute directory of the script without having the period in front, in which case you would just have the full directory and the file name corresponds to the script. So I'm going to go through how we can make a very simple script. Change my window. Okay, so I may not have mentioned this, but a script doesn't have to be a special kind of file or anything. All it is a text file that you give executable permissions. So you could essentially make or turn any kind of text file into a script. Um, General practice is to not have an extension, um, or you can choose either to not have a file extension, or you can use the .sh extension for bash scripts. For stuff like Python scripts, obviously you would have a .py instead, but for bash scripts, you can choose to omit the .sh extension, or you can leave it there. So like I said, it's just a text file. So if I do touch script, now what this did is when I list out my files again, then it created this file called script, but it's not special or anything. It's just an empty file. It has nothing in it, and it's not executable either. So if I open up some kind of text editor, I prefer Vim, but you can use anything. Then I can start typing in here, and I'll just write echo hi. So now when I look at what kind of file this script is, you can see it already knows it's a born again shell script. And the reason why it knows that is because I added this shebang line. And as you can also see now, there's some syntax highlighting within Vim. And you don't have to use Vim. You can use any kind of text editor. So for example, if you would like a GUI, then you can use Gedit right here, and everything works exactly the same. But yeah, so after you added that shebang line, now you can see that it's a born again shell script. And if I run it, I get permission denied. And the reason for that is because we haven't added the executable permission yet. So if I list long and then just look at this file, you can see, so I've already went over file permissions in a previous lecture, but I'll just do a quick summary again. So these first three dashes, or the very first dash denotes whether it's a file or a directory or some other kind of file type. The next three dashes, or characters, correspond to the owner of the file. So as the owner, which is here, specified here, so I'm the owner and I have the read and write permissions. And then these next three characters correspond to the group owner. So the group is also the group radius, so that anyone inside the group radius can also read and write the file. And the last three characters correspond to anyone that isn't the owner or isn't within the owner group, and they can only read the file. So as you can see, the last character from each of these sets of three is omitted, and that last character corresponds to the executable permission, which would be an X. But so none of the like permissions have any executable permission. So I can change that by using the chmod command and then plus X and then the name of the file. So now you can also see that when I list out the files inside this directory, it shows up green. And the reason for that is because when I check what kind of file it is, or well, I guess it doesn't exactly show the, so it's not an like ELF executable or anything, but when it shows up green, that denotes that you can run it now. So if I do /script, now the contents of the script actually run. Okay, and as I mentioned, Bash is a Unix shell. Bash isn't just a scripting language, it's also the Unix shell. Like for example, if I do /bin/bash, well, I mean, I'm already in one, but so the default shell for Ubuntu at least is Bash. So what that means is you can run essentially any command that you want inside the script. You can run the whoami command. So okay, hold on. So now it says hi, and then the name of the user that executed it. Like I can run it as root, and it'll say hi root now. So you can run any kind of command you want. I don't think I actually have NuFetch installed. Okay, never mind. But you can run any command that you want inside the script, and you can obviously see how this could be useful during the competition. For example, you could add in your script to enable the firewall. And now it activated the firewall. And there's loads of more things that you can automate within the competition, even things that you might think aren't automatable, like users, for example, or config files. You can automate the vast majority of stuff that you might do during the competition. and that will just give you a very like sustainable time lead. And what I mean by that is as soon as you like open the competition or you start your competition starts, you can just run a script and you'll knock out a bunch of easy vulnerabilities like within the first 10 minutes or so. And that gives you a lot of leeway to like kind of take your time and scan out like the rest of the file system for more obscure vulnerabilities. I'm going to go back to my slides. Okay, so the basics of Bash. So what you should know first is how to declare variables. And I'm going to reiterate this. I may keep saying this, and I've already said it, but Bash is also the Unix shell, which means anything that you do within the script, you can also do in your terminal. So declaring variables, arrays, for loops, they're all the same inside the terminal. You just can't have multiple lines like this. You would only have semicolons and you wouldn't have white spaces. But essentially everything that you can do in a script, you can also do in a shell and vice versa. So first thing we're going to go over is declaring variables. So primitive variables like strings, integers, and booleans, you can just simply declare them by having the variable name here and then the equals operator. And then if it's a string, you might have quotes. If it's an integer, there are no quotes, obviously, and it's a number. And if it's a Boolean, it's either true or false. Um, and that's how you declare variables. And then you can reference them by having this dollar sign in front of them. So dollar sign var1 corresponds to hello, and then var2 corresponds to 999, etc. It's pretty straightforward. For more complicated data types like arrays, for example, you declare arrays by using the same equals operator and the name of the variable here, but you'll have parentheses surrounding whatever you want inside the array. And notice that there aren't any commas or anything. It's delimited by spaces alone. And then to reference something within an array, you would use this notation, which is a dollar sign and then a curly brace, followed by, just type it here, followed by the name of the array, and then inside square brackets, whatever index you're trying to refer to. So this is a simple for loop. Let me reformat this for a second. Okay, so this is a simple for loop that you can do to iterate through the contents of an array. Um, as you can see, it looks pretty similar to like Python. You have for, and then you declare the variable name that you want to set to be iterating through the list, and then for I in, and then you put this in quotes so that everything is parsed as a string, and then you use that same notation of dollar sign and curly brace along with the variable and the square brackets. But now instead of like an integer or anything, you'll use this at keyword or key character. And what the at does is it essentially like spreads out the entire array. So it lists out the entire array um, in the format of like apple, banana, orange. And I'll show you guys exactly what that looks like in a second. But all you need to know for now is that this is how you would expand an array and iterate through it. And then obviously you can do whatever you want with this variable after you've declared it to be iterating through the array. This is just a simple example of just echoing it. And then at the very end, this is crucial. You need to have done at the very end of a for loop or a while loop. They're both like the same syntax. And also, as soon after the for statement, you need a semicolon and do. Alternatively, you could have do on another line like this, but I guess the common syntax is just to have a semicolon at the end and then do. Um, yeah, and that's pretty straightforward. So I'll go over this in a second. I'll just show you guys really quickly how arrays work on my VM. Okay, so we have this script which declares a variable array or ARR and sets it equal to an array containing apples, bananas, oranges. So in this line, we echo out what looks like the 0 index of the array. And here we echo the at operator with as an argument or within the square brackets. And then we have a for loop here iterating through the array again, declaring the variable as fruit, and then echoing I like, and then the fruit. So you can probably imagine what this is going to look like here. I'll just open it in a different window so you can see them side by side. Okay, so I'll go by one through this output. So the very first thing we did after we instantiated the array was we echoed out the 0th index of the ARR array. And obviously the 0th index is apples, so it echoed apples first. And then we echoed out the array again, but in this syntax with the square bracket, or sorry, with the at symbol instead of like a number. And as you can see, what that does is it like spreads out the entire array in a string format so that you can see them all like adjacent. And then next we declared this for loop to go through the array, declaring each like iteration as the fruit variable and then echoing I like the fruit. So when I like apples, bananas, and oranges. Okay, so a really quick thing that we should go over is how you can essentially execute commands and have the output be parsed within your script or within bash again, or within your shell. So what I mean by that is executing a command such as pwd. If you don't know, pwd stands for print working directory, and it outputs to the terminal whatever directory you're currently in. So this syntax with the dollar sign and then parentheses wrapping the pwd, you can put any command within here, like who am I or pwd or anything, and it will first execute the command before it is parsed within the rest of the string. So as you can probably imagine, echoing out and then this directory is, this will be replaced with whatever directory you're actually inside. So it's important that you use this syntax because doing something like this directory is pwd, obviously it's still within the quotes, so it'll just say that letter for letter. And you can't do anything like this either. This just isn't syntactically correct. So you have to have the dollar sign and the parentheses wrapping around the command. And this is a very useful syntax that you should remember, because, for example, if you wanted to like iterate through a specific line on uh, or a specific set of lines on a file, you might have like the head command, like head and then 10 lines or something, and you could iterate through like so. That may or may not work, but something like this to iterate through the first 10 lines of a file. And there are a lot of possibilities of stuff you can do syntax. Next, we're going to go over logic. So I have a big example here displaying a while loop and an ifs conditional, as well as this read keyword, which I'll go into in a second. So let's start off with the while loop. The while loop looks somewhat similar to the for loop, except what you have within these square brackets is a Boolean. So you can have any kind of conditional here. You can have a variable called like, I don't know, first name equals Bob, something like that. So we can see it later here, but uh, the way you parse through conditionals in a while loop is exactly the same as you would in an if statement. So if you just have the Boolean true, then obviously this will just run forever. And then you have the same syntax of the semicolon do, and then what happens here is the terminal prompts type your name followed by a colon, and then this read name, this read command essentially is how you grab input in bash. So after the user types anything after this line, then it will be read into this variable called name. And we'll run this script in a second so you can actually see exactly what that looks like. But so you can essentially store whatever input you want inside a variable, and then it's saved within this variable name. So next we have an if statement, and the same syntax of having square brackets with the conditional inside. Oh, another important thing to note is that when you have a conditional or something, you need to have a space surrounding the actual like conditional to be evaluated. So as you can see here, there's a square bracket, but then there's also a space. If you don't have the space surrounding the condition, then this will not be evaluated correctly, and you might get a syntax error. And same thing with like declaring variables. If I have a space around a variable declaration, like here, for example, then you will also get a syntax error or the command just won't run properly. There needs to not be any spaces in between the the variable name and what you're assigning it to. and the equals operator. So like spacing is very important in Bash for like some part or some reason. Um, so after you like store the whatever the user's input is into the variable name, then you evaluate this conditional of whether the name is equal to Steve, the Steve string, and then so you can see the same syntax of a colon or semicolon after the conditional, and then the then keyword, and then on a different line, you can do whatever you want with like you can do whatever you want in here essentially. So in this case, we're just going to echo hi Steve and then break. So if you know some other programming languages, then this may be pretty self-explanatory, but the break just breaks out of this infinite while loop. And here's the else conditional. So if name is not equal to Steve, then you'll echo goodbye and then whatever name they passed in. And at the very end, you have this fi, which is also just if backwards. And what that signifies is that it's the end of the if statement. You'll see like a similar notation for other things like a switch, for example. You might have like a case and then I don't know, case var. And then at the very end of the switch, you would have like ESAC, which is case backwards, just to signify that like whatever the conditional is or anything is over. And then at the very end, you have the done, which closes off the while loop. So I'm going to open this in my VM and we can run it. Okay, so we're going to make something called o4 underscore logic. Okay, so I'm just going to rewrite this really quickly. While true, do. Okay, making a few typos. Okay, so if I run this file, which has the same code in it that I had on the slide, then it asks for my name. So I'll just say Bob, and it doesn't work. So I don't get that message saying hi Steve because I didn't write Steve. And it says goodbye Bob instead, which was inside the if or the else statement. But if I type Steve now, then it'll say hi Steve. And another important thing to note, if I just say Steve with lowercase, then it won't register as being equal to Steve with an uppercase S because that equals sign is case sensitive. Okay, but yeah. Okay, so next, I'm just going to briefly talk about functions. Functions can be super helpful. For example, if you're making a script in Cyber Patriot, like you could have a number of different functions that execute like different things, and then have some kind of menu to like allow the user to like select what they would like to do. So for example, you can have a function called like firewall, and then you could do stuff in here like UFW enable. And then you could have like another function called like change pass or something, and this function will just like change passwords or like do whatever. So adding a bunch of different functions allows you to like for one, it makes your code more organized. Also though, you can specify different functions that you want to do at the end. So I'll just delete this here and show you the example that I already had. But after you declare a function, which you probably just saw, but it's just the name of the function followed by a space and then parentheses. And then within curly braces, you can have whatever you want it to do in here. And then the way you call a function is just by writing the name of the function again. So don't get confused by this too much. I'll go over that in a second, but you don't have parentheses or anything. You just write the name of the function and that will execute it. So as I was saying, if you would like to like organize your script a little bit better and have different functions for different purposes, like firewall, changing passwords, users, then you could make a bunch of different functions and then right before the competition or something, or maybe during the competition if you want to like double check something or you want to rerun only a specific part of your script, then instead of like sifting through all the lines of code and like deleting stuff and adding stuff, then you can instead just like type the name of the function at the very end and then delete it when you want to do like a different function. Um, Essentially, yeah. So if that makes sense, you can just organize your code a lot better, and you can also give yourself the option to only do like sections of your code. Well, I'm sure you guys are already familiar with functions, so I don't know how much I really need to explain like the benefits of them, but yeah. And then in Bash, another cool thing you can do. So notice how the parentheses are empty, but I'm echoing this statement which says you ran the function with arg and then a $1. So we're not actually taking any arguments through like these parentheses here. Like it's not like I'm declaring a variable called one here. The way like passing in arguments works in Bash is you simply write the name of the function and then you have the argument directly after. And this argument will be saved inside this variable called $1. Another thing you can do is if you want to add more arguments, so I could say foo true 999. So now I have two arguments and not just one. And as you can imagine, the way you would reference this second argument is doing $2. Another thing you can do is instead of having $1 or two, you could just have a $ at. And what this will do is it will print every single argument that you have. But we'll just leave it at $1 for now. And also, let me just check on my VM. Okay, so I'm going to show you guys another example on my VM. Okay, so we have this um, script right here. It declares two different functions, foo and bar. This first function just prints out you ran the foo function, and then the bar one is similarly, you just ran the bar function. And then we have another few lines over here which echo which function do you want to run. And then we read a variable called func from the user input, and then we just type the name of the variable here. So what this does, as you can probably imagine, is it just asks the user which function they want to run, and then it will run whichever one they write. So you can just run this. So if I say foo, it says you ran the foo function. If I say bar, you're in the bar function. I can also do some other stuff, like I can just say who am I, so I can say command. So there's really not much logic, or like the script isn't really refined. So you can essentially type whatever you want and it'll just be executed. In this case though, we already have two predefined functions called foo and bar. So when I type them respectively, it prints out whatever is inside this function. And hopefully you guys get kind of creative with this. So like as I was saying earlier, you can really start dividing up like parts of your script into different functions. So have a firewall here instead, have like change passwords here instead. And then like when you want to run specific like functionalities, when you want to do certain tasks without rerunning the entire script or deleting and editing it, then you can just have some kind of menu like this, which asks you what do you want to do, and then you can just execute it like that very easily. Okay, so that's functions. The last thing we're going to go over is editing files. So you guys probably all know that like configuring files and editing them is a really huge part of Cyber Patriot. Unfortunately, there isn't a super neat way to do this. You can do it obviously, and I'm about to go over how, but for most services, I would actually recommend you don't script them and you just edit them either manually or you have a predefined script. But for the sake of knowledge or whatever, I'll just show you guys how you can. So there are a bunch of different commands that you could possibly use that like transform characters or completely rewrite strings within a file. Um, the one that I'm going to go over though is sed. Sed, in my opinion, is like the easiest to use. There's also the tr command and the awk command, which are like much more complicated, or not complicated, but they have a lot more functionality. And I'm not sure if I could really go over both of them within this lecture. So we're just going to go over the sed command. And as I mentioned earlier, the sed command and all of these other two, they like transform characters and they replace stuff, and they can also delete instances of strings that you find in the file. And the way they use this, or the way they do this, is with regular expressions. So this first example here, we have sed, and then kind of a strange notation here. So we have two quotes. These can either be or single quotes or double quotes. And then we have an S and then two like fields that are sandwiched in between these forward slashes. So you have three forward slashes in total, and then in between the middle one, you have what's here. This is what you're looking for, and then this field is what you're replacing whatever you find with. Um, and what the S does, the S corresponds to like a function of sed. So the S here corresponds to substitute. So whatever you have found within this field, you'll substitute it with whatever is in here. And as I said, you can use regex with this. This is just plain text, obviously, so you don't really need regex for that. But a more like useful example for the competition, I guess, would be editing something like the SSH config file. I forgot actually. You need a file name at the end. This is very important because otherwise then you're not replacing anything. Um, so a more practical example though would be like editing the SSH configuration, like a common vulnerability, I guess. I don't know if this is against the rules or anything, but I don't think it is. But like if you wanted to disable root login in the SSH file, so the syntax for the SSH file, if you're familiar, would just have permit root login on one line, and then next to it, it would have like yes or no or prohibit or without password or any like other setting. So you can use the sed command to rewrite this line by searching for, so this caret looks for the beginning of the line, and then this permit root login, obviously, and then this is all regex. So you have the dot and then the star, which looks for anything else. So it can look for no, it can look for yes, it can look for prohibit password. It could literally look for anything, and then followed by the end of the line so it doesn't go too far or anything. And um, then what you're replacing that with is your setting that you want it to have. In this case, it would be no, and then you're pointing it to the actual SSH configuration file. And I haven't mentioned this, but this -i, this is a sed flag, which allows your like changes to be saved. So if you run the sed command without a -i, for example, in this first scenario, if I just ran this command without a -i, then it would just simply like look for whatever says find and replace it with this keyword, but it wouldn't actually save those changes into the file. It would just return the output of whatever that like operation has. So using the -i flag, you'll actually commit your changes to the file, and you will actually like physically rewrite the file. So that's how you use sed. Another option that you can do to like config to like do configuration is with um, like just by replacing files, which is like a very simple and straightforward way. You just use the move command, mv, and you might have all of your config files within like a single directory called myconfig, and then you might have like your SSH config right here. So myconfig/SSH obviously points to where your config files are, and then you'll replace it, or you'll overwrite the existing config, which is located in etc sshd_config, and you're rewriting that with your own. But I do have a disclaimer. This will not work for every like service, because some services like Samba or like FTP, those services have like designated shares. Also like Apache, depending on what you're trying to configure with Apache, you may have like a web server that cannot really like that needs some like specific settings, um, SSH is a pretty simple example because generally the settings like on any given operating system or any competitive image will be the same for SSH. Like it's the same few vulnerabilities for every server. But for something like FTP or Apache or Samba, you may need to just do these manually so that you don't accidentally misconfigure stuff that needs to be a certain way. Let me see if I have. Okay, so I'm going to go through an example of sed just in case it wasn't super easy to comprehend. Okay, so as you can see, I have this file here called file.txt. It has a bunch of gibberish in here. It says hello, and then I love Windows, and then Windows is the best OS, which is like obviously wrong. So I'm gonna want to change that. So you can use the sed command, as I mentioned. I'm gonna not have the I flag for now, just so you can see like how it works. But so this is the syntax. You have the S to specify substitute, and then you have 2 forward slash or 3 forward slashes, and in between these you have whatever you want to replace with. So Linux, or no, sorry, you want to obviously replace Windows with Linux to like find and replace all these instances of Windows with Linux, and then we just specify the file name. So as you can see, when I didn't have the -i flag, it just printed out the output of the file to my like out terminal. And there's an issue here though, because this Windows here did not change to Linux. And you guys can probably guess, but the reason for that is because when I specified Windows inside the pattern, I didn't have a capital W and it's not case insensitive. So you would fix that with this -i flag or /i flag. You can add flags to the very end of here, and I specifies case insensitive. So now if I run it again, it changes these to Linux properly. And but if I still run or if I still cat the file, it still says Windows. But now if I use the -i flag, there's no output, but my changes are actually saved to the file. Okay, and we're 1 minute over, but that's the end of the presentation.